The question 10 is practical application problems of multiplying and dividing rational expressions. Here we have a real world problem. Anita's yard is being professionally landscaped. The final design will consist of a circular fountain x feet in diameter in the square A. See, this is the square A given in the figure, and the circle will have a diameter x. Okay, that's the thing. And they have told the square is surrounded by a grassy area in square B. See, the outside grass is square B, and a gravel pathway, that's all the stone and mud and everything, in the square C that borders the grassy area. The square areas will be centered on each other, so the center will be the same thing for all the squares. And as shown in the diagram, the square A will have a side length of 2x feet, 2 times x. Anita would like the lengths of the sides to be proportional. Okay, they want to be proportional. For what values of x will the ratio of lengths of the side of a square C to the side B? Okay, let's write this. Square, let me just write C. Okay, square C ratio with B must be equal to the ratios of the lengths of side length with what? Over here, square B and A. So this is given away. They have clearly mentioned what the x, for what values of x will the ratio of the side lengths of the square C to B will be equal to B to A. Explain your reasoning. What diameter could the fountain have? So now here let us write the side lengths. This is 2x. What about the side length? Now this is 5 here. That means even another 5 here, right? And 3 here means this is 3, 3 over there as well. The gravel path. And so it's 2x here plus 5 and 5 is 10. Now total over here would be 18. Sorry, 8, isn't it? 8 it is. So 2x plus 8 and 8 will be 16. So it is, the outermost will be 2x plus 16. Or you can write 2x plus 10 so much plus 6. It will be 2x plus 16. Now you can see they're all proportional. So we can just remove the common factors. Now, since it's all about division, instead of 2x, and over here we have 2x plus 10 and 2x plus 16, we can all remove the common terms and it becomes x plus 5, x plus 16. I'll show you once we substitute it. So over here, C is basically 2x plus 16 divided by, what is B? It is 2x plus 10. That is equal to 2x plus 10 divided by 2x. Now just divide each term by 2. So what's going to happen is you'll just get x plus 8. Or since it's all at the center, you can just say take this side only. One of the side. Instead of 2x, it'll be x here. Instead of 2x plus 10, it will be x plus 5 only, and x plus 8 here. So it's x plus 5, that will be equal to x plus 5 divided by x. Now then, how would you solve it? You can just cross multiply and solve it, right? X plus 8 will be multiplied with x, that is equal to x plus 5 multiplied with x plus 5. I'll just write it over here at the left. I'll just change the color here. Multiply x, distributive property. What's going to happen? It's going to be x squared plus 8x, that will be equal to, over here you can just multiply it inside, or you know it's x plus 5 the whole square identity. If you know the identity x squared a squared plus b squared, you can apply that as well, a squared plus 2ab plus b squared. But I'm going to use the normal multiplication of FOIL, which many students will easily follow through. X times x is x squared. Then we have x times 5 is plus 5x plus again 5x, and lastly we have plus 25. So now let's simplify. X squared when it moves to the other side would become minus and it cancels off. So you have 8x equals 10x plus 25, and this 25 will move to the other side and 8 to the inside because 10x is bigger than 8x. So it'll be 10x. Here will be minus 25 and over here will be minus 8x. I've just swapped these up. minus 25 is equal to 2x, and divide both the sides by 2, I'll get negative 12.5 equals x. Does this make sense? Absolutely no. The diameter cannot be x is equal to minus 12.5. So this is not possible. These ratios are just not possible here. Okay, so it's practically not possible. And that would be the answer. Now, if you try putting this in the calculator, the computations just become too high and it wouldn't give you the correct answer. So this is the issue. If you, because it's a squared term, right? Over here, what happens is if you just put this in the calculator, here it becomes squared. And computing quadratics when there are rational, it just becomes crazy for the calculator to handle and you will tend to get an error. But if you just put this one over here after solving the x squared term, this, yes, absolutely you'll get the answer. But this is required, okay? This much is important to be solved out because there are, square terms. There is another way to trial and error. You will have many options. You can just put them inside the calculator and solve it and try to solve it. Okay, you can do check, that's also possible. Just put this over here and check it out. But this is just basic understanding and basic solving of the problem. And over here, the answer would be x is 12.5, but x cannot be negative value. So there are no values of x that can make this ratios equal. So this ratio is practically not possible. Now let's see over here, if the landscape architect changed the width of the gravel pathway to 4 feet, the gravel is the outer one, okay, I'll just write it out over here. This is 4 feet, okay, they've added it. And then the width of a grassy area is 2 feet. So this one, instead of 5, it became 2 now. These values are not in scale. This diagram is not in scale. Is there a value of x that would make the ratios equal? Now again, the same thing. There's x, and this was 2x. Now will it be equal? Now let's try this. Again, ratio of c divided by b must be equal to b divided by a. So all you do is just substitution. I'll take the, change the color, just substitute it. But now let's see here, 2x is same. But what about this length? It's going to be x. Now I'm just going to take from half, okay? Like I told you that time. This is x, side is x, x plus 2. And what about this side? X plus 6. Why? From half of this is x plus 2, x over here 2. And again, x plus total length is 6. That's it. So let me substitute. C is x plus 6 divided by x plus 2. That will be equal to x plus 2 by x. See, when you have a reasonably correct answer, generally you can solve this in calculator. You can try the previous inequality. Ratio. You won't get an answer over here. For this, you will not get an answer because there is square and it's just huge values, and this ratio is just not possible, practically not possible. That's why you get an error. You'll never get a practical answer. But now, what about this? Let's check in our calculators. Here the ratios are x plus 6 divided by x plus 2. This will be equal to x plus 2 divided by, so let me write this fraction, plus 2 divided by x. Shift and solve and then equal to, you're getting the answer 2. The answer is supposed to be 2, I guess. Yeah, x is 2. But if you have, say, huge numbers like the previous one, it was over here 8, I believe. Now, if you just change sometimes some values, okay, now we're getting it. But if these values are becoming way off, whereas it was 5 and 5, this is not possible. You can see the ratio is just not practically possible. That's why we are getting an error now. See, this is not the correct answer. That's not. You can just ignore it. So you can also consider that when you're getting a way off answer, the ratio is just not possible in that case. Okay, so you're just getting a wrong answer. Whereas if you're getting a proper answer like x is 1, 2, 3, then okay, that is a possible ratio. So here I'll directly write, since it's the electronic part, x, I'm going to directly write it as 2, which we got. So what is the diameter? It's basically 2. That is the diameter. And that's what we have to solve. If you want the side length of the square A, it's 2 times x. That is 4. And what about this? Again, 4 plus 2 is 6. And lastly, 4 plus 6 is 10. where they just want the diameter of the fountain, which is 2 feet, and the length, side length of the square A would be 4 feet. That is how we could solve this problem. Here now we need to compare and contrast these two given functions. Let's see what is, this is a rational function. Here x plus 3 cancels off. Okay, they both are equal. But here there's a very important thing. The original function over here initially is a rational expression, right? So whenever you have rational expression, something in the denominator like this, the denominator can be undefined. Where is it undefined? X plus 3 cannot be equal to 0, so x cannot be equal to 3, because if you put 3 here, sorry, minus 3, when I take it to the other side, it should be minus 3. If I put minus 3 here, this is undefined, isn't it? So here, they both are equal, they both are same, they both are equal. But I'll take this as 1, but 1 is undefined at x equals negative 3. This is 2 is possible at all real numbers, because there's no denominator at all. So that is the thing. And the difference is just that this is undefined at x is equal to minus 3. But if you simplify this, both are same. But even if you simplify, the original expression contained a undefined value, so that will remain. And here, Troy and Beverly are simplifying this particular equation. Who is correct? So now, since they're converted to multiplication, what's happening here? X plus y divided by x minus y. This division becomes multiplication. You have to just flip them up. Y minus x by 4, and then you have to solve it up. This there'll be a negative sign, but here, let's see what is the wrong. See, this guy is wrong, right? When it's multiplication, they have to flip it up. So Troy is wrong, Bevel is right. Here, Troy, when he's solving from division, when he made it to multiplication, he didn't flip these two terms. That's the thing. He didn't take the reciprocal. Find the expression that makes the following statement true for all values of x within the domain. Now, basically, okay, you have to solve this, but the answer is x minus 2. Okay, you can see there's x minus 6 minus 6, that simplifies. Now, how can you get x minus 2? You have basically some value up over here, down it's x plus 3 after simplifying. The answer must be x minus 2, right? So this term must exist. X minus 2 must exist. But I have to remove this term, so I'll just write x plus 3 here. So this cancels off, you're remaining with x plus 2. So here, the question mark is basically x plus 3 times x minus 2. This is the answer. Or you can multiply this and write in quadratic form as well. If you multiply this, here it'll be x squared minus 2x plus 3x minus 6. So if you simplify, x squared plus x minus 6 is the quadratic form. So that's how we write it. And here, identify the expression that does not belong with the other three. Justify a conclusion. Rational expression. See, this is having a square root, so I guess that's the one, because rational expression must be anything more than 1, or even a constant is fine. This is the wrong one. Why? Because the other three are rational expressions. Since the denominator is not a polynomial here, there are no two polynomials, this is not a rational expression. Determine whether the following statement is sometimes, always, or never true. Justify your argument. A rational function, okay, rational function, two polynomials over here, that has a variable in the denominator, okay, x basically they're talking about, is defined for all real values of x. No. Imagine x minus 3. This is not defined at plus 3, right? But if you have, now it's not defined at minus 3, but if you square it up, what happens? Even minus will be squared. So there are certain cases it will be true. This thing can be defined at certain times, but many times also it cannot be defined. So it is not always true, not never true. It is sometimes true. That is the answer. Say, for example, you have x plus 2 divided by x minus 3. This is undefined at x cannot be equal to basically 3, or undefined at x is equal to 3. Now the same thing, x plus 2, we have x squared minus 3. You can put any, plus 3. You can literally put any value of x, and what happens? It's defined everywhere. Defined at all x. Why? Because over here you can have negative numbers or positive numbers. The answer is going to be positive itself and you're adding it. So it's fine. So that is the thing. Yeah, so it's sometimes true. This is sometimes true. Write a rational expression that simplifies to x minus 1 divided by x plus 4. See, now these are supposed to be in the writing part, but still they have asked you in the MCQ part. So here there can be lots of different options or answers. Um, See, one thing, you need to write a rational expression which will basically simplify to this, right? Just multiply a same number up and down. That's it. As simple as you can do is just multiply x and x. Now you can write this as x squared minus x divided by x squared plus 4x. When you simplify this, you're going to get the above answer. Or you can take plus 1 plus 1. You can multiply the same thing. Or you can just multiply with a number. There are so many different answers. What did they do over here is basically they multiplied and divide by x plus 1. That's it. So that is the answer. These both are equivalent. And the rational expression x squared plus 3x by 4x is simplified over here, x plus 2, x plus 3 by 4. How did they simplify this? Very simple. X is removed common outside, so it'll be x plus 3 divided by 4x. X cancels. The answer is x plus 3 by 4. Explain why this new expression is not defined for all values of x. See, yes, you simplified it very good. Now there is no undefined number, but originally this was the expression. So you always take the undefined value at which point? 4x cannot be 0, right? X cannot be 0, or undefined at x is equal to 0. This will be there for any of the simplification. Yes, you did simplify, but originally it was undefined at 0. So you must tell it is undefined at 0 itself. So because the original expression was simplified, see, undefined at x is 0 itself. Write 3 different rational expressions that are equivalent to this particular. Okay, you can write various things, but a cannot be equal to 5. Why? Because if you put 5 here, it's undefined. Now, this is the original expression, right? You can write anything. I'll just write a squared by, see, I'm just going to multiply up and down by a. So it'll be a squared minus 5a. Now, this can be simplified to this original expression. I'm going to now do, say, multiplied by 3. It'll be 3a by 3a minus 15. Same thing. Let me do a complicated one, say a plus 5. Okay, and over here also a plus 5. So it's going to be a squared plus 5a divided by a squared minus 25. All these can be simplified to the given expression here. Now they have different answers. See, all these are, okay, I think so there's some same answers. Yeah, this is correct. This is the same thing I also have taken, but all the others are different. But still, it's always, over here, one thing I forgot. I took it as plus 5, right? So in this case, I have added the denominator as a plus 5. Even a cannot be equal to minus 5 because then this will be undefined. The third instance. And over here in the first instance, I multiplied a, so a cannot be equal to 0. So whenever you multiply a variable down in the denominator, you must be very careful. It'll change the undefined values, right? So that must be brought into attention. So here you can see there are undefined values, and these are the possible things. When you solve them up, you will get the same answer. So that's how we solve that question 10. I know it is a little bit of reasoning, but it's very interesting. Once you understand the concept of rational expressions, they're all very straightforward problems.